Hey, Coffee Compiler Club. We're going to talk about compilers of some kind today. I think Levo's got a demo and I've got a demo, and that's the start of spiel. We were all recorded live. Fine. Levo, you wanna take off with your demo? And let me let
Sure.
me let me turn on sharing here.
I always forget how to share the screen, but I got it now.
You got it now, okay.
Um, so I'm assuming you can see at least the left side.
Yeah, no, the right's pretty good too.
Okay. Um, yeah, so the other day, I wanted to get rid of nerd fonts because like it's a hassle to like tell people to download it, and they have like people businesses trademarks, and there's no license, so I didn't want to distribute it with my editor. But I noticed that um, VS Code Icon, they have a pretty good license, so that's what I'm using for the buttons up here, and then I could just distribute whatever font I want, and it will just work. I also changed the code so I don't have to use monospace font anymore. It could just be whatever you want, and you can see that I have like Unicode. It's I don't know how many fonts I'm gonna have to load for it to show every character, but you can see like a lot of it is like working.
Sure.
So
I
yeah,
you
it's
have
funny
been
that
fighting fonts for like a month now, 2 months.
it's more like I work the first time I worked on it in a week. The second time I worked on it like 2 days, and then this time around I just spent a day and a half. So it's just fiddling with it, trying to make it look nicer. But like I got the idea of how it should work and how many ways it could go bad if you try to, try to be clever.
It's like
So
writing
it's
a video game. You can spend an infinite amount of time try to pretty it up.
well, the thing about video games is you can choose your dependencies. Like it's not true for people's drivers because you can't choose that. But I almost thought about like maybe if I want to be clever, I should just use bitmap and like just distribute like the fonts myself, and
Yeah.
then it can follow whatever rules I want. But since fonts can be like triple the size of another font using the same size, like you just don't know. So you just can't you can't do anything too clever.
See all
So
those little symbols there, box, left, right, up, down? That was Commodore
yeah.
64. Commodore 64 characters for doing on-screen graphics with characters.
I wonder why VS Code has boxes over here, but not uh
Yeah.
maybe it's a font difference. Yeah, I have no idea. I
Yeah.
oh, I wanted to demo
Why do
one
those
other
fonts
thing.
survive the apocalypse? I don't know, but the fonts are still there.
Yeah. So I changed my code a little bit. You can see the left side here. If you I'm gonna it's
What is
probably
left
not
for
gonna
you?
show up.
Your mouse is
It's
on the
probably
right side.
oh right. I'm just gonna do a couple more here. Oh yeah, so I like got this working where you can just click and type in variables. But it's probably not gonna show up on the video.
No,
Uh,
they're
but
looking
you can see
fine.
like one frame that these are like not showing up. So
No, I didn't understand what you mean by one frame though.
so I fixed my code so it always shows the variables when I'm like moving the
But you're
stack.
moving up and down the call stack and didn't tell anybody, but I noticed on the left, the yellow bar is moving up and down the call stack.
Yes.
Fine.
So do you
Okay.
see how this is blinking over here? Actually, it's more noticeable if I click here. Oh no, I fixed that. But
Also, yeah, we're getting zoom lag, so short visual artifacts won't necessarily appear.
okay, so I was trying to show that uh, if you move up and down the call stack, uh, you'll see that not the variable itself, the right side of it's like the actual value.
The
That's
expression. Yeah.
you can see that they're not all loaded at the same time. So
Uh,
I was thinking about, do I want to delay until it shows until
no.
GDB gives me all the variables,
So
or
are
do
you only
I?
showing variables? You're not computing arbitrary expressions. I would just give them as they appear.
Okay,
And where it
because
says dash var create unable to create var,
that's coming from GDB.
right. Yeah. Don't print that. Just don't highlight V, or when it don't show V. The
Okay.
other thing is that what I want on your right is an expression, because the usual thing I do is I want a fancified toString on some variable. You have V and argc and whatever, all simple variables is great. I often have nodes and an IR, but other programming representations as well, where I have something that I want to do a toString that in particular, for debugger purposes, prints in one line, but it prints something smart in one line, as opposed to just, it's an object now, right? So the same as Java, getting to Java IntelliJ, your toString is going to get intercepted by the debugger. So you make the toString fit on one line and do something sensible. But
Yeah.
he'll call
So
toString.
so right now, this will accept any expressions that GDB accepts. Like I just like handed it off to GDB.
Yeah, you don't have anything
Uh,
that's got a toString like effect because you're writing C code at the moment.
yeah, and
But
I
in the land of
it
debugging in Hotspot, I just did something else to get me a toString off of the current node.
Yeah. So GDB does support preprinters, and I have that working for my language. And if I run this with like Boolean code, you can see that it
Okay.
uses the pre strings. So there's some support for that, but um, yeah, I think I might have to get more specific information out of you because like if I type in a variable, it's gonna show. I mean, if I type in an int, like you can see argc is an int.
Hey, you got simple ints just come through as
Yeah.
you expect. So if you
Yeah, but
do
you said smart, right? So you meant like structs.
so well, or no, something with toString for me and a node IR does something much fancier than
Mhm.
just dump struct contents. It's going to go through and do things like it has a node ID, as a very rigorous format so that I can get large prints with large counts of nodes that all line up. But the one line version is something similar. It's a node ID, a short name for the node, which I get by calling a virtual call on the node, a count of inputs, some syntax, a list of inputs, syntax, list of outputs, computed type, and these are all come from fields internal to the node structure. So the pretty printer knows to print a node ID. He knows to print a virtual call to get a short string. He knows to print an array of inputs that come in a node, an array of outputs that come in a node. So he does a bunch of fancy stuff. And that's what I meant by a fancy. I call it arbitrary function. It does arbitrary shit, produces a string. The debugger shows the string.
Mhm. Okay, yeah, I understand. Uh, it also sounds like I might need longer debug lines because
Oh,
this is
you
cut
want to be
off
able to grab,
already.
drag, and drop those. I have a
Yeah.
really wide monitor, and so I would just adjust. Like you have 80 characters wide, roughly in the middle. Okay, well, I
Mhm.
have a debug window that's 150 characters, and an edit window that's 150 characters, and a second window that's 150 characters, and I slide them around according to what I
Yeah.
want to
Okay.
see more of.
So yeah, I gotta get on that. The other thing I wanted to show is I'm gonna type and you're gonna see the line go red. So that was
Ah,
like pretty instant, and I would find that very annoying because what's happening is um, let me just
isn't that
okay.
red because it's a syntax error?
Yes.
Okay, don't use that shade of red. That's a
Uh,
very
no. My problem is that it gets the syntax error mid-line. I'd rather it do it on new lines and semicolons. So I'm either going to have to do some kind of double buffering for the
Oh, you're saying
diagnostics.
don't go hunt for syntax errors unless a user hits a new line or a
Yes.
semicolon, an obvious end of line marker. I'm done typing now. Now check for errors.
Yes.
Yeah.
Because how LSP works is you give it did open, did changes, and did close.
Hmm.
But on the did change, you give it a version number. And the LSP gives you diagnostics based on the version number that it received.
Yeah. Okay.
So instead of like buffering them up and then sending them at the new line, I want to
Hmm.
send them as I go. So so I can have it autocomplete. But I don't want this to happen. So I either need some kind of like double buffering for diagnostics, so I could
Right.
just
Maybe
show
just
them when
put
I'm ready to show it,
Maybe just
or
show a syntax error while the cursor is on the syntax error.
But like go unwind what you just typed and watch the syntax error come back.
well, I didn't actually implement deletes because this is new code, and then I had the LSP crash on me.
Wait,
If
you
I
can't
open
delete
up,
anything at all?
so I didn't. Oh, okay, I can delete, but like I can type. Oh,
Yeah,
did I implement it? I don't
you
remember
got something
implementing
going.
it.
I claim that your contrast from your red
Oh
to the
yeah, yeah, that's
neat.
definitely gonna need to be fixed. But it's just that the LSP will push the diagnostics onto the client to my IDE,
Yeah,
and I
too
just
soon.
like render it immediately. So I'm gonna have to double buffer it,
Yeah, yeah,
or
yeah,
find some option to say don't send me diagnostics yet.
yeah.
And I saw that for Clank, but I don't know if that's available for other LSPs.
No, I
So
think
I'm
that's
definitely gonna have to like do some double buffering, but that's
these IDE
What
basically
was
things.
it.
the problem with being highly responsive?
It's
Yeah,
just annoying when you type and then
yeah.
it's just like if I type in test, I should not see
You
any lines go
cannot
wrong.
sat down in IntelliJ and hit an open curly and started typing and have its now unbalanced open curlies
Yeah,
and the giant bar of red errors scrolls down the right hand side slowly,
yeah,
filling the entire screen very slowly. And then you type your 3 lines and you close it curly, and then the red lines slowly scroll down the right hand margin, cleaning themselves up. And it's just like, dude, just fucking wait a second
yeah.
before you spew a million unbalanced parens errors at me.
Yeah, so this is very relevant to what I've done in the past, in the sense that NeoVim's LSP, basically any LSP, does the same thing. You get diagnostics, they present them immediately. Now, the newer versions of the LSP protocol have a, I don't know how they call it, like a function call that you can do to get diagnostics. And so you can tell like, hey, do not publish them as, sorry, do not push them as they are created, but instead I will pull them when I need them to.
Okay, fine, yeah.
But not all servers support this. In fact, there's only quite a few. And so what I ended up doing, I don't know, a year or two ago with NeoVim is it has this functionality where if you are in insert mode, it will not display diagnostics. Similar to this reason that if you're typing, foo, the diagnostics produced are just not useful. Because if you're typing, whatever diagnostics are produced is because you haven't finished typing. But you know that because you haven't finished typing, right? So if you do like foo dot and it starts screaming like, oh, unexpected trailing dot, it's not useful. Like I know that. I haven't finished typing.
Yeah, it's not
So
useful.
what I ended up doing, there's this plugin, I linked it in the doc. It's fairly straightforward in nature. Essentially what it does, it sort of hijacks the routine in NeoVim that's used for displaying diagnostics, and it just defers them. So what happens basically as you're typing, NeoVim applies its usual debouncing and whatever. But then in insert mode, it doesn't update the diagnostics. It takes care of some other things so that if you have like a little counter in your status line, it doesn't update that either. But then when you leave insert mode, it will wait, I think by default, for 2 seconds before displaying diagnostics. And if new ones come in the meantime, they sort of invalidate that past request. So you don't get this flashing of diagnostics going on.
Yeah.
And that combined with, I think it's some language servers, you can disable this sort of diagnostics as you type. Most will not let you do that. But that combination makes it manageable because it basically means that if you're typing, nothing changes. If you stop typing for, let's say, 2 seconds, then you get your
Then
diagnostics.
things start popping up. Yeah, it makes a lot more sense.
And at its basic sort of setup, it's fairly straightforward. You sort of receive the diagnostics, you set them aside, you set a timer, and that says after 2 seconds, publish those. And if a new one comes in, you basically cancel the timer and overwrite the sort of cached diagnostics. So you can implement something like that, and I think it should be sufficient for like 80 to 90% of the cases.
Yeah, LSPs and editors and IDEs are all so full of personal choices that I have no idea who loves or doesn't love whatever flavors of things going on there. Although clearly the whole spew, you type a few characters and it spews. That's just not helpful at all. Yeah, just give me a second, dude. I'll catch up and fine. Are we done with this one? Because I have a simple demo I'm going to bring up when people are yeah. All right. Let's do that.
Go.
Nope.
Go.
Nope.
I mean, go.
Go.
So,
All right. So
Coffee
the
IDE
issue,
club is over.
yeah, we're done. You're too late. All right. Share screen. I'm gonna have to figure out how to share. Oh, why am I not sharing screen? Look at this. There it goes. Let me figure out how to do the share because I'm gonna do this. We're screw around a little bit on share because I'm gonna do editor and IntelliJ both, but I'll stop here for a second. So I have this. I'm in chapter 9 of Simple. We're doing things with optimizations on while loops. I just ran make tests down here. Here it is, make tests. It runs to the bottom, says, okay, 98 tests. That's all good.
Sorry to interrupt. Your font is really small.
There you go. I knew I had several things I always have to do and I always forget to do them. So let me go. The cat has messed with my setup here and I have got myself sorted out here. How about that? Is that big enough or do you need to go bigger?
Yeah, it's good.
It's good.
It's still on the small side, actually. Well, that's
good. That's good.
Well, I can go bigger. I'm going to stretch the screen
This
as
is
well.
good now for sure.
No.
This
That's fine.
I did notice on YouTube recently that it started saying if you want like a clear video, you have to pay for like YouTube Plus or whatever.
Great.
And it just limits you to like a really low res version. So even this
Is this
will
okay
probably not be
or
visible
not?
on YouTube.
We think this is okay or not?
This is too
A bit
small
big-
now.
Yeah, a bit bigger.
Okay, that means that you need to take your screen and go wider because your screen will stretch. I didn't change my font size. I changed the size of my editor buffer, my editor window. You're going to shrink my editor window without changing my font.
Yeah, that's perfect.
That's
Okay,
probably a good
so
idea.
this is
Oh,
on my screen, I have a very small viewport into things that blows up on your side to something large you can read. No, that's fine. Okay, so we were going to go do Amelia, I think it's like, has a real name's like Nick or something. It's something on Discord. Anyhow, his fuzzer went to town and he produced this test case. The test case here is like just this ugly thing. It says, if false, so what happens after is dead. While false, okay, what happens is dead. Int arg equals arg, okay, fine. Where the second arg is actually the namespace, namescope of the original pass-in arg that we allow one arg. We don't have any function headers, so there's one arg you can pass in. And then while false, do nothing, get out. Okay, so it's all full of dead code, fine. This test case, when I ran it here, blows up. And it says something about there's a null pointer exception because in sub I of whatever is null, and therefore you do null pointer dereference when you try to get the type field out. Okay, what happened here and what's going on? So this is a compute call in a phi node. So the file's phi nodes, I'm looking at phi functions. I am trying to compute a value, which is a meet over all inputs. So there's all inputs, compute a meet. Well, one of the inputs is missing. Now, if fees get into here, they should have all their inputs put in before you begin asking questions like, tell me what value you have, unless you have a loop. So a loop header, in mid parse, I don't have my back edges yet. So that's the in progress thing here. That says if my input region is in progress, it doesn't have a back edge, then blow up and don't bother, compute a bottom type. Is that pretty reasonable there? Let's go look at in progress. It's very obvious here. Go find in progress. It says if the last input is null, you say true, you're in progress. So don't do anything if you're in progress. In fact, there's some other things going on here. We go find here. Yeah, here's idealize call on a region. This is another people. If in progress, do nothing. Here's my control value input for a region node. If in progress, return true control always. So the theory is I'm not computing the phi node's compute value while I'm in progress. So somehow I took a region that was a loop header. I didn't fill in the back. I did fill in the back edge, so it's in progress. So no longer in progress. It's done, but I didn't get to the fee. Now the code that does that has been shared across 96 tests. They all pass, and there's no, and it's only done in one place. It's really simple. So why the hell? How do I fail? Why is this failing? So this was the bug I got to this morning, and I thought it would be
Quick clarifying question.
yeah.
Just maybe you said this, but in progress, that means you're building the graph?
Yeah, I'm building
in
the graph. So I am doing these optimizations while parsing.
Yeah, but it doesn't mean, it's not like I'm in the middle of typing it specifically about being in the build phase of the graph. Like you've got a loop that's not closed or something like that.
I'm in the middle of building the loop.
Yeah, okay, got it.
I am in the middle of building the loop here.
Yeah.
Okay, here I am somewhere. Here's partial while statement. Partial while says, oh, save some stuff, require an open paren. So here's the syntax: while, open paren expression, close paren statement. Fine. So open paren, make a loop header. I don't have the back edge, so the comment says, note we set back edge to null here. That means it's in progress. I call peephole because it just tries to set a basic set of types, but it can't do any optimizations because it's in progress. Then you do a bunch of stuff. You get a body scope, which is a dupe of the current scope. So the current scope is left lying around because you're gonna bring the loop back into it. And then you parse an expression. That's your test, and you close the curly the print on the expression parse. You put an if test, which says exit or don't. You get a true and a false. Now, when we do this in the demo, I'm going to bring up the debugger in a minute here. It's all dead code at this point. The parser will know. When he gets down to here and he says new loop node takes the current control is dead. He knows it. So this loop node will exist, but it's known to be dead. So he's parsing dead code. He knows he's parsing dead code. That's part of there's suspicious going on. There's something happens here. He should be fine parsing dead code. Other tests pass parsing dead code. Why is this one failing on me? Okay, let me go bring it up in the debugger, and now I have to do the Windows share thing again. Let me stop this share and answer any questions while I screw around with this guy, whose share is going to be miserable until I shrink it big time and increase the font here. Let me shrink him a lot. I have to reset all my windows because now the windows got ludicrous. Let me get rid of, well, I don't know how I shrank it too much. That's why. I just no hoping for it. I'm going to close the right column. Maybe get rid of this. Now that helped. How about now? One of these says do a layout, and if I can find the layout button, I'll get rid of some extra tabs that I don't care for. How the fuck do you get rid of extra tabs? In your debugger window, I want to get rid of.
Do you use OBS?
I don't no idea what OBS is, so that's probably a no.
It's a pretty easy way to, you can select a region of the screen, and then you could just put the window over that region, and you don't have to like.
Oh, I can do that. I'm okay. Let me increase the font here. IntelliJ has a thing for that, and then I'm done screwing around. I've got a much smaller debug window than I'm used to, and so important things like disappeared out from under. View, appearance, maybe presentation mode. That's not going to help. Oh, geez, that's really not going to help. How do I exit presentation mode? Wow. Okay, let's try Zoom screen share. We're gonna look. I don't know what I'm doing now with IntelliJ. It's really foobarred up here. I'm sure it's legible, but I can't find the debugger now. Let's see here. Which one here? Stop that one. Rerun that one. He comes through. Okay, here is this legible? I can live with this.
Yeah.
It's legible. You could make the screen wider without losing any font size.
I just drag it to the right.
Yeah,
I can
even
drag it
wider. You can make it quite a 25% wider.
Okay, that'll depend on what other people's monitors look like, but
There you
that's
go.
okay. So here's my crash. Okay, in fact, this pointer here. Okay, now I want to get the button. I can't get rid of that one. That one helped. Okay, and then let me go shrink this or go here. So this is a fee node. The pretty print has a two-string I was talking to the Levo just about that says I'm a fee. I have an input of a loop. That's the control input. I have a first argument. I have a back edge argument, which is null. Well, I shouldn't be here with a back edge null where my loop here doesn't have a back edge null. Let's look at the loop. He has inputs. Inputs 1 and 2 are both known dead, but they're not null. So I'm not in progress. So I have a broken situation. I shouldn't have a region with both his inputs ready and a fee not having both his inputs ready. And how the hell did that happen? So if I look at my call stack here, I'm rolling backwards up. I'm calling to get a value compute because I'm trying to do an iterate over all peepholes until stable, which I'm trying to run the peephole just calls iterate, which comes from, some sort of fee is scroll. So in loop, I'm in an in loop call while I'm rolling through fees. Here's where I stitch together their back edges. Here's where I say, sometimes I have useless fees, so I'm doing this eager fee thing or lazy fee. I don't put all fees in because most fees at loop heads, most values don't get changed in the loop. I might need a fee if they do. I can't tell till I parse the loop, so I put a placeholder in. Here I've discovered I don't need the placeholder or I do, and I make you a real fee or I don't. Somewhere in there he says, okay, go ahead and look and see if I made a junk fee whose back edge maps straight to himself and it can get rid of them. Turns out the fee's not actually built yet, so this crashes. Okay, well, I'm in parse while. Okay, let me scroll up here. Where's parse while begin? I was just talking about parse while. Parse while says, make my loop header. Go ahead and keep the head of the loop because I'm going to merge into it, make a new body. There's a dupe there to dupe a body. Parse the expression, parse the if exit test, set to the false version, and then go ahead and make a dupe for the exit branch. And then go back to the true side, parse the body of the loop. Again, if I got any continues that appeared, I have to do a little saving things to do with continues because you merge back into the header, purge into a continue scope, and then back into the back edge into the header. Then finally, I'm done. These loops don't have any breaks or continues, so I'm just looking for end loop, where I'm supposed to match the head to the roll it back around from the body back to the head of the loop, and then do a little optimization there. And in fact, I crashed there. Although I'm nested inside. So this parse while is because I'm doing a parse statement inside of a block of a prior statement of a prior while loop. So I got two nested while loops, all of which are dead. Okay. Can I figure out what's going on here? And where do I start here? This is a nasty mess. This is why it passed all other tests. So what I'm going to do is I'm going to restart. Come in here. I'm in the outermost while loop. The parser state up here is what I've not yet parsed. So I parsed if false while open bracket, but I haven't done the 0 yet in the upper left corner. That's yet to be parsed. So I'm going to put a loop. Set it to my current control. Let me stop for a second. The current control is in the scope, the current scope, which has loop 12 as $control. Let's go look at that guy directly. Turns out he's going to let me see it here. It has input number 1 is available and dead because I know the loop is dead on entry. The back edge is not present. He should be listed as in progress. How about this? No. Okay. How about I look at scoped out find of 12. There's my loop. So find just looks by node ID and gets me it anywhere. And then I'm asking in progress. Why is it not showing up in progress? Not very helpful. He says true, you're in progress. Boy, IntelliJ just, it's pretty fine. So I'm on the outer loop. I get ahead, I make a body scope, I parse the expression. Now I'm looking for trouble, and I'm trying to find trouble yet. I get an if node. The if node is here, it looks reasonable. That's the pretty print of a, going to be dead if node. If I look at the types, he says, because I'm if false, the output type is a pair, a true and a false. The false side is available. The true side is twiddle controls dead. So he's going to be dead in one direction, not in another. That's fine. So go through here. If true is dead control. So here's if true and it's dead control. Well, here's if false. Where did it go? If false. Why are you not on my screen? Anyone see where?
If true and if false are distinct from if node, because that's what the peephole is doing, is saying I noticed one side is always true or always false, so the other thing is dead.
Not quite, but you're on the right track. Here's the thing. Yeah, here's if false. Okay, so what it is an if produces two outputs, a true and a false. And everywhere in the sea of nodes that you have a singleton node produces multiple outputs that can be addressed independently, you put projections after them to slice out. So the if node produces two unique values. He produces a tuple. One for the control left, one control right. Okay, now you follow up with two projections, a true projection, a false projection. They slice out those respective pieces of the tuple. So if you look at the code up here where I said it's set up projection nodes and if false, if true, well, a projection takes an if node. He's going to label and says, I want the true side. The string true is just a pretty print. So I can tell you what I'm getting. And that's the one slice. And then I peephole it. And the keep is graph maintenance things we can ignore for the moment. And the if node for the false side, again, the false is just a pretty print string. The index says, in the tuple that if node produces, slice out slot 0 or slot 1 out of that tuple. So if node went dead at this point, which is unusual, except you're parsing dead code. So when it went dead, it meant that both the true and the false slices of the projection peepholed away to where they don't need a test. So in this case, the true side is known dead. So if true is twiddle control, I don't need the if test. It's just dead. So I throw the if test away. That was one less use of the if node. The false also doesn't need the if test because the if is just dead. He just takes the if's input directly. So whatever the if came from the head of the loop, loop 12. So the false side is where I'm going to go, and it's on loop 12. Okay. So does that make sense?
Yeah. The side that's executed gets wired in directly. The side that's not executed goes away. It's
a constant dead control. Yeah, yeah. Now you have to have the constant dead control because I'm going to parse on that as well. And so the dead parsing keeps going along the dead path. But yeah, exactly. So then on the false side, that's your exit test. Because it's a while 0, you must always immediately exit. That's all you can do in a while 0. So I'm going ahead and wire that into the break scope. That's my exit scope. So where all the breaks leave the loop, they all go to the loop exit. The no continues yet, those are lazily added if you use a continue. Then I bring up the true side and I set it in, wire it into the current scope. It's dead. I'm about to parse a statement where I'm beginning to parse knowing that it's dead. So I'm going to step over that and I hit my nested while. So now I'm in a nested while. And in fact, I know that I should be dead here. So if I look at my current scope, he says the dollar control is twiddle control. I have dead input. I have an argument that I've eagerly put in that's missing a back edge. The Z fee here, that's a lazy fee. This is I don't have a back edge yet. He's mid parse of the outer guy. There is a fee for the outer guy. It doesn't have a back edge. Life goes on. I'm going to make a new loop node and I'm going to carry on from there with the dead inner loop. So I step forward and then it took me 3 or 4 tries. I'm going to shortcut here. The scope says dollar control loop 12. That was my input loop. This is my second nested loop. He should have a new unique loop number. It took me a couple goes to spot that. Something happened where I lost my new loop node, and instead I found the old loop. Now I'm as if I'm parsing the outer loop body instead of the inner loop body. And that's where my confusion comes from. When I come down to finishing the inner loop using the outer loop's header, which is already broken, He parses along, it's trues and falses, they're all dead. He knows his fallen control is again the outer loop. It's weird. He says, that's okay, parse the body, it's empty, there's no continues. Grab my exit scope called end loop, and here I'm trying to end the inner loop, but I'm using the outer loop's header, who is in fact in progress. And that's my crash. My inner loop is not in progress, my outer loop is in progress. Somehow a fee got wired to the outer loop because I was parsing for the outer loop header, and I'm toast. So that was when I realized, okay, I kind of know what's going on, maybe a little bit. So I restarted, I'm back in my outer loop, I'm gonna step over, and I see that, in fact, my scope points to loop 12, the whole parser.control call gave me loop 12, I am looking at loop 12 as the outer loop. Now I'm gonna whip around, and now I'm in the inner loop. The falling control is loop 12. From loop 12, you just pass through to the inner guy, that's fine. So I'm gonna go inside and build this guy. So I'll get the current control, go in a new loop with a dead entry control. I'm making my new loop. I call peephole on the loop. They're not, that's a debugging flag. That just calls it, okay, go do peepholes. So I look at this guy, and this is the inner loop. Oh, it's loop 21. So I did in fact make a new loop. It's loop 21, not loop 12. So I see it right here, loop 21. That's my new loop. That's the one I'm expecting to get. It's in progress, and no optimization should apply. It's in progress. So I go to compute. Compute says you're in progress. So he doesn't, in fact, do the other piece. He just says return a control. Says, okay, you're typed as control. Now I do some asserts. Hey, the control's good. You're a new guy. I put you on the work list. I made progress, blah, blah, blah. It's fine. You're not a constant. Are you supposed to be a constant? Could you be a constant? No. You don't have a hash yet, so you're not in the hash table. Do a GVN lookup. And here's where I spotted the weirdness. I'm doing global value numbering on control. That sounds a little odd, and it's mostly because I don't want to bother dealing with cutouts here, although it actually is legit if you have a algorithm for unwinding a program dependence graph, then it is totally legit to global value number, common sub-expression control as well. But here I have this loop is loop 21. I get a hash table hit on loop 12. Now they're both in progress. How the hell did I get a hash table hit? Well, how does hash table work? Hash table says, go do the node equals call, wherever I can find node equals here. But here's the node equals call, and some hash and some node equals. So the equals call says if the two nodes are the same, exactly, identically yourself, you're true, obviously. If you have a wrong class, you're not the same. Otherwise, I know you're a node. If your inputs are the different size, you have different inputs, you don't count. Otherwise, if all your inputs match, if any input mismatches, you're false. If all inputs match, you do a node special piece test. All right, so what does this mean? It means I came in with loop 12 and loop 21 in here, and I said, get class. Oh, here, we can do this again. Here, go back to here. So, okay, this failed. Let's try again. Back up, rerun, come through here, get my types. Hey, we're all happy. Come to hash, call. Oh, I have a hash set, so I don't get to my GVN again. Well, how about that was, what the hell, dude? Okay, back up, go again. I want to do GVN. Okay, let's go find equals. All right, yeah, here. All right, loop 12 and loop 21. Those are the two guys. They're not identically the same. They are the same class. They have length of 3. They both agree. They walk. They get a pair of zeros for those first inputs, nothing. Oh, let's look at their two inputs anyhow. So here's in's inputs. Here's this inputs. Their inputs are identical lists. And that's it. It's because they're both in progress. It's because GVN does not honor the in progress flag. That's my bug. So once I sorted that out, let's see if I can get to, how about, you gonna let me get to region node here, chapter 9 region? Yes, maybe. I went ahead and figured out to use this. I added this in just this morning. It says in the equality check that equals does, regions and loops have a particular thing. If they're in progress, they should never be equal because the in progress edge has yet to be added. And when it's added, it might be different. So I can't eagerly declare them the same. So I'm going to set that up, run again. Here's my first loop. I'm going to carry on. Here's my second loop. And it says, I got loop 12 on my scope. Let me step forward. Now, if I look, my scope has loop 21. I get a new loop node for the inner loop. That's not the old loop node. I'm just going to carry on and exit, and the test passes now. So that was me debugging basically global value numbering, not honoring a node who's in progress. And in progress is always a funny situation. So not too surprising. There was a bug there.
Well, it's interesting to me because this is something I was thinking about adding for my next revision of the compiler, right? So my first approach was to just build the entire graph and then start peepholing it, which I understand is going to be slower. So now I've realized I have too many things that are going to be slower, and the whole thing is a little too slow. So, but I think you should start like a Twitch channel and do some live coding. Have you ever thought of doing that?
Oh, geez, I would just be miserably bored with myself doing that. And I don't talk out loud hugely
Yeah,
during.
the people who I've seen, I've never really watched this stuff too much, but I've occasionally peeked in on people's coding live streams. They don't seem to be talking much. So
It sounds like it'd be boring as hell, maybe. So
it
here
is
is
boring as hell, but it's interesting to sort of see how people approach problem in a way.
Yeah, yeah, maybe. So here is chapter 9.
It does make you realize that inexperienced and experienced developers basically make all the same mistakes. The experienced people just have a much tighter loop of finding and fixing them.
Huh? What could be? Yeah.
You sort of figured, oh, I'll get to the point where I'll stop making dumb syntax mistakes. And it's like, no, you won't.
But yes, experience is what you get when you don't get what you want. Having the experience, you recognize the dumb syntax mistake and you fix it much faster. So chapter 9 was supposed to do like while loop trivial optimizations. So I had an example of that. Here is a test. That's one of our chapter 9 tests that just counts to 10 and as a break or continue. And it has the dumped SVG output. So I'm going to change windows again here. Stop share, go back to this share, share screen. Yes, share. Go to GraphViz online, paste it in. Okay, so here is GraphViz. People see that maybe the big graph on the right. There is a start control. There's a loop header. There's a fee for A. A gets initialized to 1. You add A and 1 again in the body of the loop, which becomes the new value for A at the fee. So that's what the double-headed arrow there. You also take the added value and compare to 10, which you do a test. Then you have 2 regions. Well, one of these is the break or the exit region. One's the continue region. So here's the continue region, which has only the one input from it's true, so keep looping, and it follow the control edge backwards, and you go back to the loop. And so that's the loop with this region being junk. Oh, you can't see my mouse, probably. How do I... Ooh, don't quit zooming out there, dude. Well, I don't know how to unzoom. Oh, look at this. Okay, that worked badly. What the hell? Oh, it's this here, reset, boom. And then the second region on the lower right is the exit region. And again, it just, it's a junk region. So that was the goal, was to optimize those regions away. And I can head down that path to show a new peephole. I didn't practice it, so there's every reason to believe that I'll screw it up as I get there. If you want to watch that one live, or I can be done. So silence means I'm going to carry on and you're all doomed. So
Yeah, go.
yeah, right. And so, okay, so in this case, there's a region here. It has one input. I want to say that should be an identity on the control of itself. And I should fold it away, you know, on as one input. So let's go look at region again. And somewhere in region, I have an idealized call. So peepholes that change graph shape are all done under idealized calls. This one does something already. It says, if in progress, get out, do nothing.
What idealize mean?
Idealize means replace the node in question, the this pointer node, with a new node that is in some way more ideal, or null if you can't find an improvement. And
Sounds poetic. Oh,
yeah,
what?
okay, so what does more ideal mean? It means you generally reduce the graph, or you reduce some property of the graph. So it has to monotonically shrink the graph in some dimension of monotonicity. The usual monotonicity drop is you remove an edge, or remove a node, just flat out remove a node. So here I'll show you another example here. Let's just go to plain old node. Yeah, plain old node, go find peephole here. It's going to be calling iter. That's not what I want. Where did this thing go? Calls iter. Here's iter. Okay, so here's iter. So iter is peephole is replace the current node with a better one if you can. And he calls iter, and iter returns the inverse statement.
We're
which is-
still seeing the graph.
sorry.
We're still seeing the graph. So
Here you go. Thank you. Too many windows to pop between, but now they're all sized correctly. Okay. Yes. So let me go back a second here. Let's go to, let's talk about iter. So peephole. Peephole's the main one. Iter is peepholes in a loop. So peephole says, I'm going to improve the graph somehow, replacing the current node. In the case of idealize, that is what you would do on a particular node. There are several improvements that are default for all nodes, and we've just saw them a minute ago. And then there's some specific for regions, some specific for adds and multiplies and the like. So iter returns me something that is inverted for what peephole needs to return. So there's an inversion test right there. But let's just look at iter for making progress on things.
so do we have to see the code because I'm still seeing the graph? Maybe you can stop share and
I claim I'm sharing the
I see the code.
IntelliJ.
oh, so it's me. Okay, no problem.
I also see it.
Okay.
You see
then
IntelliJ
it's me.
or the graph.
Okay. Oh, the graph yet. So I will see it. Go, carry on.
I see the code.
You see code.
Okay.
All right.
Okay.
Wow.
I can see your mouse cursor blinking, so I mean, it looks live to me.
Okay.
Yeah. This is the simple project, chapter 9, node. It's simple source main Java, simple node.java. So coming through the iter, I'm looking for ways I can improve something. Everybody has to have a value computed for them. That's a compute of a value type. And that'll be part of further optimizations post parsing. During parsing, we'll use that type to say things like you're a constant or not. So there's a computed value. There's a monotonicity test here, which says that if you're brand new, you don't have a type, so you get old as null. But if you've been around the block a few times as a node, you'll have a type. You got a new type. The type it's always is-a. So that's monotonicity. Monotonicity saying you always improve the value of the types. Get thrown on the work list if you've never been seen before, or if your types change, you made progress, that will cause other things to throw in the work list and repeat until, ad nauseum. Then I ask the question, if you're not a constant node, but you type as a constant, well, I'm going to do an improvement. I'm going to take your node and replace you with a constant. So dead code elimination here says I am throwing away the current node and replacing it with this constant value. Because I'm in the parser, there are no uses of the current node. I came in here as a first time with a new node. So the dead code elimination is a fairly simple implementation. It just throws you on the floor. And you're constant now. So if you had an add of a 1 and a 2, now you're the constant of 3 and the add 1 away. It's fine. Global value numbering says if your hash is null, 0, what does that mean? It means that you're in or out of the table. So that's one of the special flags we say that you've already been hashed or you haven't. If you've never been looked up in the table, we call get, that'll set a hash. And then if we miss, we'll put you in the table now and you have a hash now. So the hash flag of 0 is correctly saying that you're in the table. Otherwise, I found a prior identical version of you. So I set your hash back to 0 because you're not getting put in the table. And I dead code you and replace you with the thing I pulled out. So that's common sub-expression elimination. Everyone does it. Get rid of the current node I just made and return your prior. Then I call idealize, which again, if it returns not a null, I'm going to replace you. And whatever you return, I'll go ahead and peephole it one more time recursively. And then I'll throw away the current guy and use the updated version things. So that's sort of common improvements that everyone does. Add node has a fairly let me subnode might have a little simpler set of idealized things. Yeah. So here's idealize for subtract node. Quit that. Which is to say, if your own 2 inputs are the same, well, you subtracted yourself from yourself. You subtracted a minus a. Well, that's always a 0. And I replace you with a constant 0. Otherwise, I return a null saying I can't make any progress with you on subtract. So does that answer what idealize does?
Wouldn't there be a peephole after the new const node there?
It turns out that the idealize guy is going to call peephole. So every idealize call that returns a new node doesn't itself need to call peephole. That'll have one already.
Okay.
If the idealize call returns a stack of new nodes, which add node does that, the in-between ones do need to peephole. And the idealize, the final exit one coming out, does not. So add node has these more complicated ones because there's lots of ways to restructure. Oh, fuck you.
So there's an implicit.
Yeah, there's an implicit.
Whatever you return.
Yeah.
Called a peephole on whatever you return.
So here's adding of 2 things. I'm going to return you a multiply by 2 instead of an add of a and a. So the new constant on the inside of the type 2 does get peepholed, but the mul as a final exit does not. So that's all.
So is that just to reduce the number of times you have to call .peephole, or is there some other reason for that?
It's an engineering hack because as you write more and more and more peepholes, they become a large fraction of the core optimizer, and you want them to be robust in a number of ways. And one of them is you don't accidentally return a node that itself immediately has an opportunity for further optimization. So you always want the peephole to happen on a new node that's coming out of idealize. So idealize just calls peephole. Now having idealize call peephole means it's redundant for me to call peephole here. I could. It will do whatever and return the optimized new mul node after peephole's done with it. Then I'll call peephole again on the optimized guy who should have already had peephole himself called already. And it's just the last peephole is always redundant, extra, and doesn't help.
Right.
So go ahead.
Maybe it's not a relevant question right now, but just like wondering, what point do you check whether the peephole was actually complete and
Right.
check that a redundant call to peephole wouldn't actually do something? Is that just a test suite?
Right. While I'm parsing, I don't do that test. Post parsing, I totally do, and that's supposed to cover what happens in parsing. So let's see here. Capital.
Yeah,
Let
makes
me
sense.
find it. Maybe. Yeah. Okay. So this is the iterate in a loop. While work is pop is not no. Well, I get some off of work. If it's dead, throw you away. I don't care. Oh, call iter. That's that code we just looked at for iterate. If you get a change, now that I have some users, I have to do a full graph rework. So that subsume says you made a new node. It was not the same as me. I'm going to have to replace one node with another, do a whole graph, then walk all your inputs, outputs, put them on the work list. So the neighbors on the work list, and then assert progress on list. And also coming in here with assert progress on list.
Yeah.
Okay.
By the way, just another question. This is something that I ran into, and it got more and more annoying as my graph got bigger, that I wasn't able to just stick to immediate neighbors getting pushed onto the work list to keep things valid.
That's correct.
What I had to put onto the work list got to be a more and more complicated thing to figure out.
Right. So in the land of simple, we haven't reached there. AA fights that problem all the time. I've put infrastructure in place to guarantee that I have it correct. And it catches me pretty quickly.
As well, but I mean, I only guarantee it through tests, and then I have this function called neighbors, which is ridiculously expensive, and it's searching all sorts of different things depending on what kind of node it is.
Okay, so what I do is in AA, so this is AA, not simple. So speaking of ridiculously expensive, progress on list is in fact linear in the size of the graph. Since it's in a work list, this makes this work list go quadratic. So if you remove these asserts, you'll go back to being linear. This assert in particular, if it's removed, you'll go back to being linear. With a certain place, you're quadratic. And that's because this guy says, start from the stop node, the bottom of the world, walk the entire graph. If any iterer makes any progress, it's not null, I fail the assert. So I attempt to apply iter to every node in the graph unless it's on the work list. So everybody who's not on the work list, I apply iter. If I made progress, it was a bug, you should have been on the work list.
It's probably something useful to have in place while you're on the early part of the development.
It totally does. And as I add peepholes or I change how I'm structuring the graph or whatever, I routinely find a crash later that says, something wasn't right. I re-enable the assert. So the assert keeps coming and going and coming and going.
Yeah.
So I never actually get rid of it per se, but I'll turn it off when I'm doing larger testing because the quadratic is just too expensive. Okay. Also, as a debugging thing, the count here counts me a trip count, says useful for debugging. It lets me binary search which people caused the graph to go sick. It's commonly a case, what really happens is one of these iters crashes or progress crashes, and I pop it up in the debugger and I get a count directly. Now I set my breakpoint prior to the count. I stop right at the count and I walk into the iter in single step, and usually the crash is obvious. So that's one of the other hacks here. So does that answer the question of how I verify? I didn't go the farther neighbors one. I have a strategy in AA, which I don't have code here to talk about. I was going to finish up doing the region optimization.
Yeah,
but then we'll go back and talk about neighbors not more than one removed.
Yeah.
Okay. So this code here it's almost a direct identity in AA. Plus you have a separate set of neighbors that you throw on, and then there's a separate set of assertions to make sure that that's correct. And let's get to there later. Okay, so back to my graph on the left, not this one, but the other guy that I was doing, the while 1 less than 10, A++, whatever, had extra regions. So I want to get rid of extra regions. So I was back in region node. And I was trying to look at idealize on region. And I said I had something here and it says in progress, do nothing, get out. That's great. Find a dead input, which does the obvious thing for I is 1 to the number of inputs. If I have, why is it in type of, X control. If your type is X control, if your type is the dead type, you're a dead input, I want to get rid of you. So as a region has multiple merging paths, one of the paths is dead, I want to wipe it out. If I find a dead path to wipe out, I have some outputs, which will include my fees. I have to simultaneously update all fees in the region in unison, so the fees in the regions all map the correct inputs for the correct selection of the fee. So that's why this is done at the same time. I'm hacking all the fees and the region all in one go. Once that hack's done, I've reduced one of the inputs on the region. If that region himself comes down to 1 live input, so he's always at a 0 slot on a region, which carries the, for everyone else carries control. For a region, it's always just less blank, so it aligns with everyone else. So it says input 2, but it's your last input. So if you're a region of 1 input, go ahead and become that 1 input, N of 1 here. And if I had any fees, I need to go fix this. I haven't finished this code. This is the code I'm trying to get rid of. I'm trying to run this code, this stanza here, to get rid of the dead region. But it's only triggered if I first deleted you from 2 inputs to 1, not if I started you with just 1 input and now I want to remove you. So I'm going to outdent this code, and I can do this in Emacs, but I'll figure out to do it here. I'm going to outdent this code. Okay, where did I miss here? If I probably grabbed the wrong thing, I want to outdent this code here. Okay. So now what this code says, if I find a data input, go ahead and delete it, and I return this, which is a trigger to say, go again. Not null. I return null, I said I'm done, there was no progress. Here, I say, go again. So if I find one dead input, and I have a region that's merging 17 inputs, 17 input paths, you can get these. Well, I deleted one of them, now I got 16 input paths. Go again. Maybe I deleted the different one. Keep repeating. But in any case, when I come back and I don't find a dead path, if you have only one, do this code. So now I want to go back and run the other test, which is none of this one. Let's go find the other test. I think it was left in chapter 8 test. That's near the bottom. This guy. Okay, so what happened here? Well, I changed something and I blew a regression test. Oh, I changed something because the test is asserting that its input, the exit path has a return whose control is a region. I'm exactly trying to get rid of a dead region at the end. So the stop has an input, which is a return, who has an input on his control, which is slot 0, which is a false projection of an if test, not a region. So I did something to this test. I don't have the correct exit test. I'm just going to remove that assert for the second so I get a graph out. He ran, he spewed a graph. I'm going to select the graph here. I'm going to go, I have to stop screen share and restart on the other guy. We're going to go try. Now we're going to get a graph again if I can screen share on it. Share or wait people. Maybe put it in here. I got to delete my non-control paste bits. Let's see what happens here. Oh, interesting. Okay. And this is where I got when I knew I didn't yet have it sorted out. So my graph output still has a dead region, but my assertion says there was no region. So something broke. And that's the reason I'm confused here.
I thought the assertion said that there was a region. Did I get that backwards?
The assertion was looking for a region and didn't find it. So let me re-enable. Let me just stop here and go again. And this is where I claim I was trying to make progress. I'm surprised.
Remember, we're looking at the graph still.
Sorry. Oh, you're looking at the graph still, of course.
Yeah.
Thank you.
Question. Is this your normal workflow? Like, are you running a test and pulling up the graph and taking a look? Or do you normally, is that just more for our benefit? Do you normally look at it maybe with different representations?
Right. So I have a couple different work modes I'm in depending on what my goals are. So the graph looking is a thing I do when I have reached the point where I'm passing all tests. Graphs, I do graphs for optimizations. So the first thing happens is I have no bugs. I have no crashers. So I run all tests, they all pass, there's no crashers. Now I'm looking at graphs saying, is there stupid things in the graph to get rid of? Oh, here's a dead region, I should get rid of it. Let me add a peephole for the dead region. When I'm done, I'll go add the peephole, get the crashers out, and then I'll go back to the graph and say, did you get rid of the dead region? Also, I'll have an assert that says you got rid of the dead region, and then I'll look for another peephole to go do, or I'm done looking at peepholes and move on with other things.
Yeah,
so I'm using the graph to say things look sensible.
Yeah, okay. Yeah, that's just what I was wondering. Yeah, I do similar. I was just wondering if that was how you do it.
Okay. I don't even know what I was doing here. I was in the Yeah, okay, so I'm in IntelliJ. I'll wait till people says they can see screens. So in IntelliJ, I ran this test. The assert I commented out would be failing, but the assert was saying, and it was passing before I changed the region node peephole, was saying, I'm expecting stop to look backwards to find a return. So here's a stop node. I'm going to his inputs. He's got a return node. So looking backward on his slot 0, he finds a return. Okay. Return has a dot control in the assert down there at line 208. So look at this return, his slot 0 we control. He finds a false, not a region. That's the exit path from the loop. So if I take the false and I progress again, he's got an input, I get an if. Well, that's the if that says, look at the phi of +1 and 1 less than 10. Okay, wait a second. Let's try pretty printers here because I'm getting big. Print of depth 9. I got this. Go view. Okay, so here is a ASCII only dump. Starting at we can start the start here. I usually start the bottom, go backwards because I dump from the bottom up. Here's the start node. He has some uses in the square brackets. That's the uses, 4, 19, and 6. He has an input of, he's always control because you just ran the program, and he has an int bottom for his argument 0. That's fine. There's a constant 1 here. Okay, what is this? This is node number 6. Has a constant 1. Has an input 2 to start. Node 19 is your constant 10. Has an input to start. Nodes are all hooked. Constants are all hooked on start. So all constants hook immediately to start. That's why you see them done that way. Node number 4, it's a control node. It's a control projection slice from start saying, give me the control slice of start. I am the control for the rest of the program. There is no slice for the arg because this function doesn't use the input past arg. So there's no slice for that there. Here's a loop. He has always slot 0 is dead or empty on regions and loops are just regions that you know you have a back edge. His input fallen path is number 4, which is the control here. His back edge is 21. That's this if true down here. He has a phi. He's merging A called A. The A is just there for funds. It's debugging help. It has no purpose semantically. He's gated by this region called loop number 7. And he's either picking between the initial value, node 6, which is the constant 1, or the back edge value, which is the add. So there's node 16, and that's your add. And the add is adding from the node 15, which is the phi. So that's your tight data loop here. These two are the tight data loop. We're adding one in a tight loop inside the loop body. Fine. There's a less than test who takes the result of the add in node 19, which is your node 19 here is your constant 10. So if you're less than 10, do the test, whatever. So this code is what I expected with all junk regions removed. So my pretty print is busted. Not my pretty print, my graph dump is busted, not my graph. My graph is correct. My graph dump is busted.
I have one thing that's confusing me here. Why are you pinning your constants to a region?
I'm pinning my constants to the start, not a region.
Oh, why do you pin them to start?
So I can find them in a backwards walk. They have no purpose for that pin except to find on a backwards walk.
Aha. Okay, makes sense.
Okay. So that's purely an engineer, no semantic meaning. It's purely an engineering hack. It means I have no nodes that have no inputs except start, who I squirrel away in a global variable. And stop has no outputs, who I squirrel away in a global variable. And in AA, I mix start and stop, call it root, and it's pinned in a global variable. So you have a graph. At some point, you have to do something about the ends, because the people in the middle, you started from a node and you always relative jump to the next node, from a node to the next node. You always have relative motion from node to node to node, except to begin with and to end with. So those have to be pinned somewhere in global so you can find them, and then you have to decide what to do. So if I left a constant 1 with no inputs, and I wanted to start at the start and walk forwards and see what I can reach, I can't reach a constant 1. It has no inputs. So that fixes sort of trivially a forwards reachability problem.
Yeah, that's right.
And
Yeah, I
start
think
is
I
not the same as
gathered all my
main.
constants and just had them as in a place where I could jump onto them. So I didn't have them linked in the graph, but I basically did the same thing.
You put them in a global that you could link onto them. You could start on them. Yeah.
Yeah, like I had an index that I could find them by.
Right. Well, I find them by looking at the reverse of start. And then
Yeah, makes
Aaron,
sense.
you were asking.
I was just saying start is different than main as a concept.
It's basically main. Yeah, it's main. I don't have function headers yet because simple hasn't gotten that far. We're doing the core guts, not the inputs, outputs, you know, like the hello world. The world's hardest program is hello world because it's got var args, it's got IO, it's got var arg print functions, it's got the start call. It's like the worst possible thing to start with. So we're not starting there. We're
Once you have-
basically writing expressions and parsing and building code to run expressions.
Once you have multiple functions, do they each effectively get a start node until?
Depends on how you want to do it.
Yeah.
A way to do it is just that, and you compile each independently. A way to do it is to say I have a whole program root. It has multiple functions. I have function headers, and I would replace start with a function header, like maybe it has a name called main as one of its pieces parts. It has a bunch of arguments, not just one, it has multiple arguments. They probably all have types that are hooked on it. So there's a bunch of things I want to throw onto a hypothetical function entry point. But it would subsume start. It would do the start for this kind of a graph for the function body. If you look at C2, he's always starting at a function header point, and then he inlines furiously elsewhere. So I have effectively a start, which is some function header, and C2, it's not a one input integer only input header.
Yeah.
Okay. Oh, so from here I can go a couple ways. I can go try to debug why my graph printer found the old graph. Probably I have a bug in there somewhere for that one. I suspect I found the old graph. I can go turn off my region optimization I just added and pretty print the graph again like here, and we'll see the regions that are in it. That'll confirm that plus or minus this one peephole, plus or minus this regions in the graph. Or we can close up and go on to other topics. All right, big silence again. People are still interested.
Well, I wanted to ask another question related to start nodes, but
yeah,
it's a bit ahead of where you are with simple. But since we're stopped here anyway, okay. Is start node also sort of spawns all of your global variables and constant type of stuff, right? Or not? Yeah, global variables.
I don't have any global variables in simple.
Yeah, but eventually it would, right?
So eventually I would have something that I would claim is outside of a function header that would have static globals. So
and then that,
start here is really a function header. So I need another layer out. I need a file scope where I have static globals. And then within the file scope, I have several functions. Start would be a function header. It's doubling at the moment as the file scope, but I don't have any place to hang primitives. And I mean, static globals, so I don't have any.
Yeah, okay. So that basically answers the question I wanted to ask. Like, you know, you've got multiple function headers and then you have multiple things. So yeah, you basically just create one scope further out.
I need another, I need one more scope out. And then if I'm building on multiple compilation units, I often will add another scope out that says, here is this compilation unit, and here is a proxy for all other compilation units, which I'll never compile in this setup, but I'll call into, I'll import globals from, I'll import things I can call, I'll hand my functions out to that unknown rest of the link step, and I'll get those functions as callbacks passed into me and shit like that. So I'll have...
So it's the thing that's playing the role of the world.
Yeah, I'll have a thing that I'll call universe or world, something like that, yeah. It's everything else. Now in AA, root plays that part. The root node has his semantics are, I'll take the input, the returns from all functions that I'm compiling. I'll pass all possible arguments to all these functions, including returns from other functions because they went through a callback that I could internally do because I'm the world. He plays the role of the world. But you could have a node for that. Makes it mentally a little easier to track because root plays other parts. He is the starting point and the ending point for all my function headers and my function returns and the like, and be useful to split out a separate world just so the graph connectivity is broken apart from the semantics of what world can do with things.
So do you just sort of pretend that world is any, no matter what you ask from it, no matter what you pass to it, just assume that that's valid?
In AA, I went ahead and had root world be limited to things that it can obtain from compilation units that I have. If I pass a function as a return out to world, world might call it, and it might hand it back to me. If
Is
I
that going
don't
to cause
pass
you pain when you get to dynamically linking against other stuff?
Yeah, it makes, well, it's semantically, it's local. I get an optimization. If I don't pass a function out or I don't pass an object out to world, it's local to the compilation unit. I know it's local. It will never alias. If I make a localized security key thing and it doesn't escape root, root can't peek into a security key and root can't pass the security key back into me or to anything else. So I can ask the question, does this security key escape root? If it did, you know, maybe I want to throw a security error at you. So I totally track aliasing lifetimes that escaped or didn't, and whether functions escaped or didn't. And that limits what world can do.
So as you expand the scope of where what your root node is, will you change how you pin your constants? You pin them to the rootmost node?
I do in AA. It's just in this phase. And when you get down to actually code gen, of course, the constants swallow in instructions and you clone them for free and all that kind of shit. But in the scope of the compilation unit, they'll pin to the outermost scope in whatever my compilation unit is. In AA, the compilation unit is all the functions I'm handed all in one go in whatever code I'm looking at. So yes, the constants will float up to root.
Right.
Okay. I'm going to go.
How do you decide how greedy to be in deciding what the compilation unit should be?
Oh, that's sort of, you know, personal choice of what your goals are here. A totally sane goal is to say the compilation unit is a function, but then you don't have access to global variables. And then another sane goal is to say the compilation unit is a file. And I have access to everything in that file in the same compilation unit, all the functions and all the static globals, whatever they are.
But if I have imports that are just files on the local file system, there's something we said for be as greedy as possible.
Right.
Just keep going till you're stuck.
Yeah, right. And then, right. And you can just keep adding more and more and more. Depends on how you want to deal. So if you add a world to your root, then you can have all possible things I can import and whatever effects happen outside of what I can import, because that's what the future linker will hand me, will do to me, what the future world will cause me. So you kind of go through these steps here of how much you want to deal with. Adding world in is not hugely difficult. You have to think a little outside the box. And once you get it done, it's not a lot of code. Once you get it sorted out, it's pretty straightforward. And then it gives you a little more optimization, a little more opportunity to do things. In particular, like the no escape thing means I can start taking shortcuts on structure layouts and allocation points and the like if you've never escaped. I get all kinds of fun optimization.
It's making me think of the stories of Julia that tended to have very small compilation units.
Yeah, you lose scope.
Did a lot of linking.
You lose scope if you don't have a big enough compilation unit. In particular, the no inlining thing, because I cross a compilation boundary, gets kind of painful. So C compilers will typically, within the same file, inline furiously, because they have all the code. And that's great. And files are often semantically, mentally different things. So the opportunities, the lossage for failing to inline across different files isn't as big because they're not so related. And then people got into, well, I'll have the linker inline, and I have link time optimizations and whole program scope optimizations. These things all have come and gone, and they're around still. So yeah, you can take it as big as you want or not, or whatever. So simple, we're starting small for obvious reasons.
Yeah. The two models
Okay.
in my head that I feel like are pulling in different directions is, on the one hand, I really like Python's top-down evaluation style.
Mm-hmm.
I said Python, gave it the name of a file. As soon as it hit an import, it went to go process that file. The whole thing becomes this nice tree.
Mm-hmm.
And there's just sort of a well-defined order in which things happen.
Mm-hmm. Mm-hmm.
And on the flip side of that, there's something nice to say. Go grab my entire program and compile it before you start executing it all, because maybe I'm some high-speed trading thing that doesn't want to go out and do any compiles. I want even the very rare case of I need to pull out of the market entirely to still be fast.
Yeah, yeah. Especially the bailout. Yeah, yeah. You have your daily trades, your moment by moment trades, but you also have but get me out. And that one path has to be fucking optimized. Yes.
Right. If get me out is like, oh, I don't do get me out very often. Let me compile get me out right now.
Mm-hmm. Mm-hmm. Force that sucker, make sure it's fast. Yep.
And if the
Let me
answer is, well,
dynamically
those
download the
import statements never
dependencies for
ran
that.
until you hit those code paths.
Yeah.
So none of that code has been, let's go do a bunch of disk operation.
Right. Sorry, Derek. What were you saying?
I was just going to say, I just said, let me dynamically download the code for that and then compile it.
Exactly. Exactly. While the market's in free fall. Yeah, yeah.
I
Node
actually,
update?
I wonder if you've done anything with Simple on error reporting or handling it. So like,
No. I mean,
no, yeah,
yeah, but nothing.
And so
nothing
I'm
fancy.
wondering,
Yeah.
just in general, then, do you do peephole rules which are specifically designed to, report an error, or
No, peepholes are semantics only.
yeah,
Let me find. Here's the kind of thing going on here. There's no recovery. Syntax error. Error is throw new runtime exception. Syntax error says expected syntax, but I got whatever I got. So require says I need a piece of syntax, and that says if I got my syntax, just return, otherwise throw an error. Here's another one, require an ID, expect an identifier, found, blah, blah, blah. These are all just halt and die.
I thought errors became error nodes and had the potential to propagate.
in
So if I had
AA
a syntax error inside a dead.
Right. In AA, errors that are recoverable in the parser become nodes in the graph. And if they're dead at compile time, then that's fine. In simple, all syntax errors, and we have almost no semantic errors, but semantic errors will just be instant death. We'll just throw you out.
yeah.
To get fancy, the goal of AA is to be simple and mostly approximate what you'd expect in a normal language. So no fancy new features in simple. It's really, this is a tutorial of how a normal language does normal things.
Yeah, I think error, some level of error handling is, it's something that I've been thinking about, right? So my first pass on this, I just basically, if there's an error, it just blows up, and up to me to figure out what the stack trace means. But and because I was doing pattern matching, what would happen is that if I had an error, usually meant that no pattern match. This is usually when I'm building the graph, and then I'd always end up with an error, which is can't no local variable if or something like that, because the sort of last thing in the pattern matching is, oh, it must be, look it up to see if it's named, and then it's not, there's no variable named if, therefore it's it's an error. But the real error is that I did something wrong. It's like the if statement doesn't have a body or something like that, something stupid.
We have
And
we have some tests I'm showing on the screen that says stuff like that. Here program says make a new variable on one arm of the if test, and then return it, but it's not available on the other arm. So that's an error. Cannot define a new name. Here's an error that says make a local variable b equals 2 in one arm, make a local variable b equals 3 in the other arm. Doesn't matter, it's defined on both. They're both locally scoped. When you exited their scopes, they were gone, so you can't return it. and so on and so forth. So
Mhm.
these are all not done by graphs. These are all done by the parser looked for something. What am I looking for? Cannot define. Here we go. So parser says something here. What I got here? Parse if. Require an expression with the closed require for the close on the if. Put an if node in with its true and false projections. Set yourself up for a scope to save for parsing the false side. Go ahead and parse statement on the true side. Set control to true and parse it. Set control to false. Parse it. Only if you have an else. Maybe you don't have an else. Okay, fine. So match on the else. Then come down here and say, look at the things that were defined. If I define something on the true arm, or I added a new definition to the false arm, then, boom, dead.
Yeah. Which is an interesting, case for detecting an error, but it's kind of a weird error to actually have. But, that's okay.
These are all things that, because the fix on the user side is so trivial, you hardly notice them. You just blow through them. Oh, I mistyped, and you correct the type and you keep going.
Yeah.
But the parser has to check for it. Somebody has to check for it every time. Or you're getting these weird states of nodes that don't have definitions and graphs that can't be serialized because they have defs on one arm and not on the other, whatever. You get some weird situations going on.
Yeah.
You build a broken graph. So you must test for it. All right.
Yeah.
That was it, unless we want to go track down why my graph pretty printer is printing the old graph. I probably missed something stupid, but I don't have it in my head, so it'll be slower debugging.
I can show an optimizing problem, or actually it's more like why didn't this inline, but I haven't looked through it too much.
Yeah, you were talking
So
about Discord. Yeah, go for it.
Okay, let me just clean up my desktop and
Come on.
I'll share the screen.
But if you close all the windows before you share your desktop, we won't know what your bank accounts are.
Well, yeah. So,
Is that what you're calling porn these days? Bank accounts?
I'm sure Pornhub's got a bank account.
there's actually a couple of chat logs with my sister, but yeah, let's just say bank's account. So for whatever reason, okay, when I compile my IDE with GCC, it's extremely fast. When I compile it with Clang, it's not. So let me just
With all -02 the same for them both or whatever.
so if I pass this into Clang, so -r is remark, and it's going to tell me why I missed inlining.
Wow, you actually
So
passed those flags in?
my make system, my lake build system does it. So yeah. So anyway, it basically said the cost was like roughly 36% too expensive to inline. So I don't know why GCC inlines and why it's not too costly for GCC. This is the Clang output.
Okay, so this is the function that is calling and didn't inline. This is the function that did not inline, or the function that is?
This is the function that did not inline. So I just want to scroll down so I can show that it's
that's big enough to not inline typically. You probably have some fast path cutout that needs to inline and didn't.
Yeah. So let me just show the code, like the
it's
actual C
marginal.
code.
In C2, I'd call it a middle size, depends on what other things are going on. So here's your skip path. Do you have any profiling, personalized profile data yourself on what paths in here are fast or slow? What's the common thing? Like, is it common in the case that cursor right raw is in fact 0 or anything like that?
Okay, so I don't do profiling because for GCC and Clang, it's always slower for whatever reason. I should try it again on the IDE, but so far it's always been slower if I profile.
Yes, you profile, it slows down, but you get some knowledge. You then go back.
No, I mean when I use profiling guided
I'm
optimizations
not talking about
tends to
that.
make my code slower.
Yeah, I'm not talking about that. I'm talking about
Oh, okay.
you profile, and in particular, many profilers do not profile interesting data values, but frequently you'll know something interesting about the data values. And then that
Okay,
might
so
turn into like there's a fast path in here. Like your
this
unlikely outdent equals count. If it's unlikely, I'll tell you right now in C2, throw in another function. Say
so
if
this
outdent.
this one is so outdent count only happens if I select a few lines and then I press Shift Tab to
Yeah.
outdent to like go to the left.
Let
So
me explain why I'm talking here. Put it in another function, skip length shrinks, and the cold code is somewhere else. So
yeah,
keep the if test, if outdent, but call a function, do outdent count, and move that blob off to outdent count. That takes skip length down probably in half or more in terms of volume.
yeah. Are you saying I should figure out why it's not inlining by changing the code?
Yeah, I'm saying change the code. Do it right now.
Okay,
While we walk.
right now.
Here's your demo. Yeah.
I'm not exactly ready to build,
I
but
know.
I can do that.
Fine.
But the thought was this
What's
is
wrong with this
is
IDE? I thought you built one.
He's not using his IDE. He's trying to debug his IDE in another IDE.
I'm not really trying to debug anything. I just noticed that Clang didn't optimize. But
No, if it's
I-
too slow
I
to be usable, then it needs to. That's a bug. It's a
so
performance
I'm
bug.
just
Yeah.
There's something to be
um,
said for debugging a thing with something else.
Yes, I have.
When you're at Google and you realize for the first time that DevTools is a website that's rendered with HTML, and you're using DevTools to try and debug DevTools.
Yes.
But of course, you hit the bug in DevTools while you're trying to do the thing to find the bug.
While I was one of my first early experiences there was writing a kernel debugger for an embedded system that didn't have anything, and then trying to debug the kernel debugger using the kernel debugger, and that sucked. I mean, eventually got there, but holy crap.
Yeah, that sounds not fun.
Yeah.
a kernel debugger like Linux kernel.
Yeah, I have a little embedded system. It doesn't have any OS. It's driving a piece of hardware. It's complicated enough. It had two CPUs, 68,000s back in the day. One of them's directly managing hardware to roll paper through a printer and run a laser printer in a mirror to spin the laser across the mirror, and you get the print to laser print. And the other one was parsing PostScript and trying to build an image, then compress the image down to what you could slice through a bit slice computer. So it was a third computer, it was a bit slice computer in there that ran the laser. That system got complicated enough that I wanted a debugger in the system. And that meant I had to write one because this is pre the time that you would have such these things you could just go grab off the shelf. There's OSs, embedded OSs nowadays you could get that have a kernel debugger baked in. It's all good. So I wrote a tiny
I
little
take it the
kernel debugger.
fourth REPL was not sufficient for this debugging?
Exactly. No, I had hard real-time constraints. I had multi-processor constraints. I had, I don't know, all kind of other things, and complicated, like PostScript parsing itself is pretty complicated. So we did PostScript analyzing, debugging, optimizing, blah, blah, blah on, x86 standard desktop machines of that era. And then we baked that fourth down onto the 68,000 because we had a thing that we could just do that. That was part of the game, the work I had done with I had a fourth IDE. A graphical fourth IDE. We baked down from x86 to 68,000. That got us to where we were producing large, complicated bitmaps that were compressed. Now we had to go turn them into bit slice computer business.
Okay, so you can see the frames per second was about 1,300. So when I do
three numbers with a wide standard deviation doesn't say very much. Run 30 numbers and computer standard deviation and average and standard.
There's a reason why the middle one, I mean, there's a couple of reasons why the last one is faster than the middle, and the first one I guess is just like the warm up.
I'm saying random numbers makes for a bad debugging, profiling, performance experience. fucking do
Yeah.
statistics. Statistics here means run it as an easy first approximation, run it 30 times, not 3.
Okay.
And report the average and standard deviation.
Okay. So I guess I got to do that.
You have to hack your build to
offline.
say, don't run it 3 times, run it 30. But now just do the math. The standard deviation is just sum and sum squares, and do a little math on the sum squares, and you'll get standard deviation out. Every website in Planet will use standard deviation. So I'm looking at your numbers. You're bouncing all over the map. The first number is clearly slower than the third number, or whatever. FPS is supposed to be higher is better, yeah. But you're bouncing all over the map, so I claim you need statistics now.
Well, one of the reasons is because I don't actually close the window like at the same
It
time.
kind of doesn't matter. So what I'm saying is the lack of statistics means you can't tell the difference between a random number and the fact that you didn't close the window was important or not. You said one of the reasons is, and one of the reasons is no. You're in random land, dude. You're making random guesses from random stuff. Get some statistics going.
Okay, but I can just say that every time I ran this with GCC, I always got higher numbers.
Yeah, that's
And
fine.
I did delete this, so I don't exactly. I guess I actually got to like go really deep into this.
Yeah,
because the answer, I guess,
if
not obvious.
the
But I'm not sure why GCC is much faster.
The pass you did a second ago had 1200, 1200, 1100. This pass has 14, 15, and 1900.
That's because the other one was Clang. This is GCC.
Okay, so those are significantly apart, but I claim run enough runs to get some serious statistics because you have a large standard deviation. Then you can make more bold statements about its GCC versus Clang and whether being out of the function or in the function makes a difference.
Yeah.
Or how much
Okay,
difference.
I gotta script that because the reason why the reason why some of it was slower and versus faster is because at the beginning, um, it's always checking if the text has been indented. The middle is where it's indented, and then after that, it doesn't have to do the check, so it's like less work.
Well,
So that's why that's part of the reason why like the second half is always faster than the first half. But yeah, I'm gonna script this so I get a consistent run every time, and then I can like go down into it. But I was just wondering if it was an obvious reason.
If you know that there's a different amount of works for each of these FPSs you're printing out, that's significant. And you should try to arrange that the FPSs are for the same actual work units. If the first pass does more work than the second, which does less work than the third, then you have 3 different sets of numbers. Here's a number for I did the work for outdenting. Here's a number where it was already outdented. Here's a number that was the same as this, whatever it was going to be. But you get different numbers because they measure different things.
Yeah. Okay. I think I'm.
Okay, you're done. But I'll be happy to see this demo next week too. If you
Yeah, no, I was just like thinking, what's like a large file I can like run through this, but it's going to be the same problem because I don't actually know how many lines the first second will process, and I would basically have to like figure out a way to repeat it, and yeah, it just might right now it's just like
get your benchmark.
I basically need to generate a file instead of like use a real source file.
Well, you can copy a real source file off to the side and declare it your generated test file, and it's not a source anymore, and it just goes stale, and you don't care. It's a sample of a big wad of code.
But the first second and the second is going to be processing different line lengths and different code density, and it's not going to be consistent.
So yeah, I claim you need to get your benchmark harness sorted out.
Yeah.
Before you do performance work.
Well, it's more like, why is GCC not as fast as Clang? I mean, why is Clang not as fast as GCC?
But well, the first answer is, it's not clear to me that that's true because your statistics aren't legit. It might be the case that they were doing different kinds of work, but in fact, one was as fast or as faster than the other. But I claim you can't tell yet that one was faster. You're eyeballing, you're in the old Mark 1 eyeball, which is kind of
Well,
okay if you're 2x or greater.
Remark did say it didn't inline, and GCC clearly
Eh,
did.
Yeah. And it could be that there are 1,000 other things that he did or didn't do. There are also the things. So first you get to point where you can, with decent statistics, tell that one is fast, one is slow. Now you can start doing sort of delta manipulations to see what improves or what doesn't. Like it could be that Clang has a million fails all over the map and he's just slower all around. Also, he didn't inline this. And the million tiny cuts of death have killed you as opposed to just this one inline.
Okay, yeah.
Or
Okay, yeah.
or it could be the one inline and you're spot on, but you have trouble reading the numbers because, like I said, you're bouncing plus or minus 50% all over the map.
Yeah, it was more like it told me it didn't inline, and I was just curious why GCC did. But
Right.
yeah, I got to do the test if I want to really
Right.
get into it.
Right.
So,
Yeah, you did a little
all
more
right.
work there. Yeah, and you're
Well,
doing
yeah,
speed work.
I'm gonna take your answer as you have to figure out how to make it inline and figure out the exact cause of why it didn't inline as
No,
the
my
reason
answer is to first cut, get your profiling legit, statistically correct, so that you're not fooling yourself as to what is important and what's not.
Okay,
Now,
yeah.
once that's done, there's another question of, hey, this didn't inline. Why or why not? Is it important? Did it matter? First, sort your statistics out. Otherwise, you're just fooling yourself. You chase
My
rabbits.
question wasn't about too much about slowing, about why isn't this inlining? Because I was thinking about what optimizations. Or okay, whatever. I'll say that for like another time.
The function I saw was large enough that it was not a slam dunk no brainer to inline. And in the land of C2, if I have profiling data, which LLVM does not, then I can tell, I can make that call. I can tell. If I was writing a static compiler, I would have to look at that function in scans, and it may or may not cover the thresholds, your borderline. Now, knowing personally what those frequencies are on those if cutouts for big chunks of code, I can suggest that you split the function yourself into a fast part and a slow part. And the fast part's much more likely inline because it's smaller. And that might do the job. Might get you the speed that you were thinking you'd get. And I have this large cat in my lap here who's.
I've definitely wondered that before when I see functions that have an if with a tiny happy case and then a long, complicated error handling case.
Right.
It's like, is this worth the iCache, or should I actually in some way outline the else of this if, because it doesn't happen very often?
Yep. Now that's still a good thing to do. If it's really, really rare, C2 will have a cutoff after inlining the whole thing, doing the test and saying the rare case is so rare, I'm going to go to the interpreter. But it has to be super rare to do that. Otherwise, he just says, well, I'm going to eat however many 1,000 bytecodes if I inline it, and maybe I don't. Whereas if I manually cut it into 10 bytecodes of fast and 990 bytecodes of slow, well, the 10 fast go in, that's no problem. And then if you do the slow, well, you're another compilation unit, fine. But you're on the slow path, so who cares? All right.
Do you have any way that you use to measure the size of a function in AA or anything?
In AA.
Or in C2, I guess, but.
Yeah, so C2 always had inlining in the wrong place, and this has been known forever and a day. It inlined at the bytecode level because history. And at the bytecode level, we have approximations that we do by looking at the bytecodes. But if you're to inline later in the compilation process, you could do several things to improve that, including inlining pre-cooked IR, compile the function once already and save it as IR. Now it gets optimized by the IR, but you leave it in IR format. Then you can count the size of the IR and whether or not it has shit like hot loops or it's going to get embedded in a hot loop or whatever. So you know more about the call site and you know more about what you're calling, and that can help you with better heuristics.
Yeah.
C2, sorry, yeah, that's fine.
I was thinking about ideas about doing something like the idea that I sort of have in my mind is that you do something like that to measure the size of the function that you're going to inline. And then you put, you inline a function, and then you measure yes, and then you inline the function, but before you optimize, you measure the size. Then you try optimizing and measure the size and see if, you know, the difference is significantly related to the size of the thing that you inlined or something like that.
I never did that because the theory was, by the time I got on optimizing, unwinding to not inlining was not worth it. It was too much grief.
So a variation of this idea, and I think that's what Graal does. You have your inlining candidate represented as in the IR. Then you have a call site where you have possibly more specific types or constants. Basically, you have more specific context at your call site.
Mm-hmm.
You can create a clone of your candidate, replace your arguments with this refined types, refined like ranges, constants, basically with new facts, and then run some optimizations with these refined facts and compare how much do you gain from getting these extra facts. And if it's something noticeable, well, it's probably better to inline.
Right, that's a good plan. There is some extra work, but the fast slope cases here, if you have a known case, you get constants, you got nulls. It's obvious thing. You pass a bunch of nulls in.
Now, wouldn't that miss some of the opportunities that might be there in terms of, like
you don't get? Yeah, it does.
Oh, yeah.
The issue is how much work. You can go infinitely far down this path. There's no end to it, right? You have to decide when is it worth staring at it or just be done, walk away.
Yeah, I mean, it seems like it would only be worth it if the thing that you're thinking of inlining is somehow marginal in the first place. If it's a tiny function and it's just a home run to inline it, then it doesn't make sense to do that stuff.
Right. You get these Midland things. So there's big things you're just not going to inline, and then there's little guys you're always going to inline. You get the Midland things. Now what?
Yeah,
that's what
Arthur. But the thing is that even for the big things that you think, oh, I would never inline it, using a method like this, you might be able to discover that you've got a bunch of if stuff that's actually dead, and it's actually small once you figure it out, right? So, but I was also thinking, and I remember seeing this
just like an Arthur
in C2 where, or maybe I'm mistaken, but I thought there was something where when you do an inline, you actually put an if statement in it, and then you have like, if I'm going to inline this function, and then you've got the function call still there, and then you inline it in the, in the else, in one branch there. And then
that happens specifically for hot slope path or common, uncommon V calls.
Yeah.
Not for sort of, I have a V call I want to inline. I have several implementations. I look at the profile of the receivers. If there's a hot guy.
Yeah.
Okay.
I was just thinking that mechanism seems like it could be used to, you do the inline, you optimize it, and then based on whether you like it or not, you set that branch to true or false, and either the inline goes away or it's kept.
Oh,
I don't know if that.
Yes. Oh, maybe. The fact that you have an if test does screw with other optimizations.
Oh, that's true.
You don't get a perfect answer no matter what. Arthur, you were trying to say something, yeah.
Yeah, I think ultimately, when you are deciding to inline, you have a choice either to somehow predict what will happen after you inline. And this idea with specialization is about prediction. What LLVM does, just looking at the IR and looking at the facts and trying to count optimizations. That's one way. The other way is what you suggested. Well, let's actually try and see what happens. I don't know of any compiler that does this in practice. I think because it's just so more expensive.
It's a lot more expensive, yeah.
Because you are not talking about you're not talking about one inlining decision. You have like dozens, if not hundreds, inlining decisions, and then it's a combination of them that actually will bring you benefits. So just the space you need to explore and roll back is just huge.
Right.
And also one thing about the place where C2 does inlining. This approach has one benefit, and it is compile time. So if you are in the land of just-in-time compilation where you try to balance compile time and performance, it might be an okay trade-off, because doing this late, generating IR for inline candidates, working, optimizing them, costs a lot. It's very easy. You can double your compilation time just by doing this kind of exploration, because you generate IR for a function, you run some passes on it, and then you decide not to inline. That's a wasted compile time.
No, yeah, I would never go there. Like if I were to move inlining and C2 forward, it would be, I would take the basic compilation, okay, all right, and then without any inlining except maybe the most trivial things, stop and look at all the call sites and see, do I think you're hot? Do I think I know who you're calling? Can I inline? Okay, now should I? And make a decision, including shit like look at all the constant targets getting passed in, but not necessarily cloning the target, immediately testing it. But the growl thing said, I'll spend some time, take it. And in this kind of a model, I'm assuming that the target has also been compiled at some point, and I've kept a copy of his IR. Now that I have a copy of his IR, I can immediately do, here's call site things, here's the target IR. Is there an easy, something happened right away? There's another one, I take the IR and I clone it. Now it gets expensive. This is what I was talking about. You do this 1,000 times, it's pretty expensive. You take the IR, clone a copy, plug in your constants. Did it improve? At some point, you have to stop and say, this is too much work to go sort out the next level. I want to just get the job done, get out of here.
Well, I wonder if the growl thing with the clone can actually, then you can actually use the result that you've done. So you measure it, but you don't
you measure it. Yeah. You have to. That's the only thing that makes sense. You make a clone. It just goes what you just said. You would basically inline it under an if test and decide, the if says basically, I'm going to tick the call version or the other version, and the rest of the optimizer doesn't know which way I'm going to go here. And you optimize, and then you stop and you look, well, if I do this, I get this giant wad of code and it didn't clean up very much or not. And one of the things that goes on here is if you inline too many middling things, you get iCache blowout because the inline copies are inlining themselves, other things sort of ad nauseum, and you have a middling function that you end up with 27 slight variations of floating around. And the 27 slight variations blow out so much iCache that it would better off to not inline. Each one improved a little bit. You're better off not to inline, have one copy and one copy in your iCache, not 27 copies in your iCache. That is part of the heuristics that C2 uses for inlining. If you've already been compiled and you're already of a sufficient size, I don't inline you again because I don't want to blow out the iCache. I just say, fine, done. So there is a thought there. It's middling. I get a little improvement, maybe. Well, if it happens once or twice, it happens 27 times, you're losing iCache big time.
Yeah, so this goes to another thing I've been thinking about, which is the order in which you do it. It seems like you really need to do kind of leaves first globally, and try and doing leaves hopefully will get you more leaves. You want to get recursive.
You're talking about ahead of time or on the fly?
Ahead of time.
Yeah. Okay. Yeah. You come to but you could just do that recursively. You're doing totally ahead of time. You're in the middle of compiling. Somebody makes a call. You might want to inline or not. You look at the other guy. Has he been compiled once in the bare version? No. Well, recursively go until you hit a leaf. It's done. You backed up. This compile then decides to inline or not. You back up and you back up and you back up.
Yeah.
So we do so LLVM does this bottom-up inlining exactly. For us, since we are starting with specific top-level compilations that we requested, we don't have the whole call graph, so we need to explore the call graph starting from the root of the compilation. But what we do and what we find is very beneficial is when we generate the IR for a candidate, we would also do some trivial inlining into this candidate. So in a way, it is like a bottom up, but only at one extra level.
One more layer in.
Yeah, and what
You have
it
to get all
does,
the getters, et cetera,
it
too.
it's remove all the getters, all the wrappers, and kind of makes the semantics of the function more understandable for the inline cost analysis.
Yeah.
And then we do some kind of simplifications, and it will also do some like commenting between getters and setters, this kind of stuff. And yeah, it is beneficial. It lets us see better what the functions are doing, and it lets us see better what kind of optimizations will kick in after we inline. But cost compile time.
Yeah.
So yeah, this exploration of this extra level deep, I think for us it's something like 30% of compile time. Just doing this, just generating IR and
Yeah, well, your compile time is a lot bigger than C2's, so
yeah,
you know, shouldn't have grown at it. Yeah.
Yeah, but I think in general, any attempt to go further in the exploration of the call graph, yeah, it is it's just prohibitively expensive.
Yeah. All right. Well, my wife came home. It's lunchtime. I'm looking for a break here.
A couple last words. Matt, I tried that inline thing that you suggested. I tried both the inline threshold and by using the force inline attribute. Both brought up my the second frame at really, really high, but not quite as high as GCC, but it's very close. So
You
yeah,
try splitting
like,
the hot. You
yeah,
try
I was
manually
about
splitting
to
a
do
hot and
that.
cold.
Yeah, I was about to do that, but you know, it's time.
Yeah. Yeah.
Before we wrap up, I want to do just a quick half-hour presentation on Gradle and Git.
I got my machine gun ready. I am ready to start shooting at targets here.
Inside joke.
Jeez.
And then we will discuss exceptions. I'm sure we all agree this.
Yes, exactly. Everyone will be handed small pointy knives, and we're going to have discussions about exceptions versus Gradle. And we'll see who's left standing at the end.
I'm still smiling.
Oh, I'm telling you, dude, it's time to like look at alternatives, and you're like, no, Gradle to death till I die. Okay, Gradle till you die. You're dying. There you go.
So one quick question: is ecstasy will be have a package manager or something to manage the code or something?
Yeah, need a package manager to manage our programmers.
So a quick suggestion: do you kind of explore the Unison programming language? Have you heard it? So
I've looked at it in the past.
yeah, so it's packing of good ideas. So it's worth at least keeping an eye on it.
So
Sounds
you'll
like a
have to-
great topic for next time.
You have to learn it and then come fill out a bunch of feature requests on ecstasy.
There you go.
Yeah.
All right.
Okay.
Until next time.
Bye.
Cheers.
Bye.
See ya.